And this nobleman was a gambler. He loved to gamble. So he went to the casino to gamble. And one time, he played 2 games. The first game he played, you know what's a die? Huh? It's a die, right? So there are dots there, 6. No, right? So he would roll a die. Now, he can draw a die at most 4 times. He can draw first time, second time, at most 4 times. Within the 4 times, if he gets a 6, then he'll be a winner. So it's the first game that he played, right? So roll a die, throw it. What's the number there? Okay, it's only 1 to 6, the die. Now, the second game he played, he drew 2 dice. Roll 2. And he's allowed to roll maximum 24 times. If he can get 2 6s for the 2 dice, 6 and 6, he's also a winner. So he tried to play this game in a casino. And he thought that these games had the same probability, it's equal chances. But somehow, as he played these 2 games, he kept on losing money. So he didn't win much. Sometimes he win, but as a whole, he's been losing money. So he was a bit frustrated. He said, there must be a way for me to win this game. What can he do? By the way, he was a French noble, right? So he called Blaise Pascal because he knew that this guy was a mathematician, very famous during his time. He said, you please help me. At the same time, another person by the name of Pierre de Fermat, that's a name. Okay. This is another very famous mathematician during his time there. So he called these 2 mathematicians, said, please find a way for me to win the game in the casino. So that these 2 mathematicians work together. And eventually, both of them created a theory in mathematics. It is called what? Probability. You have a probability? Okay, I'll tell you what that is. Probability. You are going to learn this one. I think this one is what? Grade 9, isn't it? Maybe this year you'll learn it. It's a measure of chances. How good the chances are. You follow me? How good the chances are. Huh? Now, in casino, we talk about chances, right? Chance of winning, chance of losing. So in other words, we want to find a way to measure how good are my chances of winning a game. You follow me? So that is called probability. It's a measure of chances. And you will learn this one in your email, by the way, to share with you. And these 2 persons created this theory called probability. So probability basically was born in a casino. So this is a product of a casino. It comes out, but turned out to be very useful, not only for gambling, by the way, but also useful in many other areas. You see that? I think that when you go into it, you'll find that probability has been used in business, in economics, in science, almost everywhere. Not just because it was born from a casino, but it turned out to be something very useful. So there's a story behind this guy here, Blaise Pascal. Okay, share with you very quickly. Okay, fine. Let's get off here then. We are not going to go to this anymore. Okay, we come to this one called curve stitching. I give you the paper here. Okay, pass around. I'll tell you what to do with it. Pass around. The paper here. Come on, pass around. An extra, pass it back to me. I will give it to people. No, okay, I think there's some behind. Just a minute. Pass around. And the extra, pass to me. Pass the back. Take it. Everybody got one. Okay. Pass around, pass it back if you don't have. Everybody got one. Give to me. Give to me. Yeah. Anybody? Got it? Everybody okay? Everybody got one? Okay. Now you are going to do some curve stitching. How to do curve stitching? I tell you what is this all about. Oh, is it beautiful? It's a design. Now, it's a form of what we call string arts. People use string to do it. They can create all kinds of very pretty pattern, okay? But what do you see? These are, by the way, these are not curved. These are straight line. String, the straight line, right? You pull a string, it's a straight line. So they can form all kinds of patterns. And of course, you can also do it on the grid paper like this. Since we have no string, okay? This one actually they can do it on the cardboard or whatever it is, but since we have no on the paper there. So what you do is that we can join the points with straight line. Use a ruler. You follow me? No. So you have ruler here, or you have a ruler. Make sure you have ruler. You got your pencil or anything. Fine, doesn't matter. You can use a pencil. All right. Now, what I want you to do is that I want you to, first of all, I want you to draw this one. I'll tell you how to do it. Once you finish, I want you to do the other one. This is called the parabola. Have they learned quadratic? Not yet. Quadratic curve in grade? No. Okay. This year you will learn something about a quadratic. Okay. Now this curve, you see that? Is it a shape of a curve here? This curve that you see is called the parabola. Okay. This one is got four sides here. It's called the asteroid. And all these have name, by the way, all these shapes have a name, and they're all formed by straight lines. Now, how to make this kind of a shape? You watch this video. Watch very closely. See how the line works? Okay, so then let's go back to show you the last one. You see how it's being done? Now, what you can do is that you can take this paper, don't just use whole sheet, by the way, you will draw another way. Take the top part. You see that they're having what? 1 from 0 to 20. This is your so-called x-axis, right? Or horizontal axis. This is a vertical axis here, and y-axis here. Number, same thing. Now, how you draw the line, you can see that just like what he's doing what? He will draw this one, 20. You see the line all the way to what? 1. You follow me? So 20 will join to 1 here, and then 19 to what? 2. So like this, 1 by 1, until you finish all the line, and you will get this curve. Now you draw and see what happens. Mark to 20, and you draw it. Don't use the whole page, just use the top part or the bottom part, fine. You decide, okay? Hmm? No. Oh. It doesn't have a message. One. Yes, let's put together this one extra. Oh, you don't use the whole piece of paper. Okay. Yeah, no ruler. Use no, make a small one. No, it's so big. It's only to 20, 0 to 20, 0 to 20. It's easier. Yeah. Yeah. Don't use whole. Don't use the whole page. You got it? Yeah, it's a nice curve you have. Okay, good. You see that? You got 13, huh? You can go a bit bigger if you want to, up to 20. You see what happened up to 20? Oh, you're going up to 13, huh? Okay. You got a nice curve? Good. That's it. You see a nice curve, huh?
Wow, thanks.
Yeah. Now you can see lots of patterns already if you have finished the first one, okay, those of you who want to do the second one now. Oh, okay, never mind. I will see. The rest is still working. Let me work on it first. Okay. Oh, beautiful curve you have, huh? Good. Oh, you draw a big one. Okay. Beautiful. You do the design. Well done. You can do the four sides. You can have the one. Okay. Complete all the four sides, then you get it. You can be more creative. Some of them create a very beautiful patterns. They don't on four corners. Now, for those who want to create the asteroid, you can carry on watching this video. Come on, that's how the asteroid is being created. Watch this video. Oh, sorry. Okay, you have your axis here. Okay, then you can label not too big, 1 to 10 on one side. Okay, 0 to 10 here. Here you go what? 0 to -10. Fair enough. Your x-axis. Then same thing here, 0 to 10, 0 to -10, and just draw as what you have done earlier on then. And you should be able to create this asteroid. You can create that one there. If you need more paper, raise your hand. Okay, there's some extra papers here you can use to draw the asteroid. You can draw this one here, okay. You want paper? There's some paper here, they want. Okay. Just raise your hand and then you will get some more paper. There's one here, there's one here. All right, sister, you're very creative. You created other shapes also using this parabolic curve. Well done. The lunch is 1 hour, isn't it? A lunch 1 hour. No, it's 1 hour.
No, until 12:30.
12:30. Okay.
What is the bicycle demo? After.
I think that hey, the Alex guy who brought the sure.
How do you draw it?
Draw what?
Draw this.
Oh, this one. Okay. Okay. That's right. Okay, how do you draw this one? Somebody asked me this question. You first of all have make sure that you got the x and y axis here. All right, your x and y axis. Then you label it. For example, this is the dot here, right? The dot here. This is a 0, 1, 2, 3, 4, all the way to up to you, maybe up to 10. This up to 10, for example, up to 10, okay? Up to 10. And the same here too, okay, all the way down, -1, -2, all the way to -10. And do the same thing here also. So up to 10 here, this one up to -10. You follow me? And then you join the line same. Okay, just join 10, you join to 1, right? And then 9, you join to 2. So keep doing all the 4 sides. So yeah, after you finish one side, you do all the 4. That's how you get to this shape. Okay. By the way, those that finish this one, we call it asteroid, right? But in mathematics, it's also a math name, by the way. Math always got name for things that you draw, right? By the way, this shape is the asteroid. In math, the name is always in the form of equation. It is what? X to the power 2/3 plus y to the power 2/3 is equals to a to the power 2/3. That's the equation for the asteroid. So, okay, but don't worry, I just give you the equation there. You don't need to worry how to derive it. I'm not asking you to derive it, just give you the name of it. This is what we call that in mathematics. Sorry, back color. No, I mean there's a name for this kind of shape. In mathematics, it's called by this, described by this equation here. That's all. Yes. In mathematics, all the shapes have equations. Many of them. They have a name here plus the equation altogether. All right. So, and this can also be done using the computer. The computer, you can draw it very nicely. They can do the plotting and all the things here. Well, we still have a bit of time. I think we can go on to the next topic. Or you, okay? Yeah. We may not finish it before lunch. Don't worry, I'll continue on with the topic later on there. Let me get out from here. Nope. Okay, it's about gear this time around. We talk about gears. Well, I got two small little gear here. I can pass around a little for you to see. Okay, these are the gears. This one actually was done by your third floor, the STEM room there. They have a 3D printer. And they bring me this gear here. Okay, so that's what I can show you the gear now. Let's look at the gears. Gears is everywhere in the world. Am I right? You have seen gear before? Yeah. Yes, gears. Gears.
Gears are simple machines composed of interlocking toothed wheels. They have two main functions: changing direction. Turning one gear turns the other in the opposite direction, altering the force's direction. Multiplying force or speed. Different gear sizes allow multiplication of the applied force or speed. Smaller gears moving over more distance can multiply force, while a larger gear turning a smaller one can increase speed. Examples of gears in action. Fishing reels. Gears help fishermen pull in heavy fish with reduced effort. Motor vehicles. They enable transmissions to control power to the wheels, optimizing acceleration and fuel use. Industrial machinery. Gears manage speed and force in components, boosting manufacturing efficiency. In bicycles, varying gear sizes connected by a chain let riders fine-tune pedaling speed relative to bicycle speed. Lower gears mean faster pedaling but less distance per stroke, while higher gears mean more distance per pedal stroke. Gears are versatile tools that bring efficiency and control to a wide range of applications, from everyday devices to industrial equipment.
So I'm sure all of you are familiar with gears.
Don't forget to subscribe.
Okay, thank you. Now, and there's lots of math in gear, by the way. Gears are very important. You look at, I got these two here, right? Now, this is a bigger gear, this is a smaller gear. So when I put together, if I were to rotate it, you can see it match very nicely, right? So therefore, now, is it possible that when two gears put together, they may not mesh very well? It's possible. So there must be something to make sure that they will mesh very well here then. Now, what's the secret about it? And that secret lies in mathematics. And so that's what I'm talking about, you know, the so-called math of gears here. Now, let's look at a gear. Look at a picture here, since I don't have for you to do the hands-on, okay? In fact, I got, wow, this is an industrial gear here. Somebody brought to me there. Now, there are many gears in this case. It's clean, by the way, okay? So there are many gears in this case. And then I will tell you what is this for later on, all right? I just put it here. Yeah. Now, let's look at only one gear. What do you see in the gear? We have lots of what? We call it the teeth, all right? These are the teeth. So the teeth of the gear. So that's the name of the teeth of the gear here. And you can see that in a gear, if you look at the teeth here, you got two types of diameter. One is called the what? The pitch diameter. look at the pitch diameter. It's not the diameter of this whole thing here, but rather it will go to the middle, somewhere in the middle. You can see that somewhere in the middle, cut across here. It's not up to here. It's only up to here. It's only up to this point here. Whereas the other diameter is called the outer diameter. So there are two diameters. One is called the pitch diameter. The other one is called the outer diameter. Now, what is more interesting is the pitch diameter. Why they only measure up to this point and not all the way there? It is because if you take a bigger picture of this gear here, you see this gear is not really sharp. You see that it go up, it will bend slightly. It bends slightly. All right, you can see it go up and then it bends slightly. So that's how. So therefore, this circle here, which is called the pitch circle, only go up to this point where it bends. That circle is called the pitch circle. You follow me? And therefore, the diameter of the pitch circle is called what? Pitch diameter. That's the name of it. Then what is a pitch? Pitch basically talking about the distance between two adjacent or two neighboring teeth here. The distance between two teeth here. That distance is called the pitch. So that's how the name, you get a pitch here. So the circle is called the pitch circle. The diameter is called the what? The pitch diameter. You got it so far? I'm just let you know all the terminology first. Okay, now, of course, there's a lot more things in the gear, but this is a very simplified one. Now, there are also different types of gears. This is not the only one, by the way. Okay, you look at other types of gear. And this type of gear is called the spur gear. That's the name of it. S-P-U-R. This type of gear is called the spur gear. You got many other types of gear, okay? They all have different names. So, but for the purpose of this workshop here, I only use the spur gear to show you what that is. Now, they say, okay, what's the math involved here? First of all, the first term that you will learn here is called the match. I use the letter M to denote the match here. What's that? That is the ratio. Now watch out. The ratio of the pitch diameter divided by the number of teeth. What is it for? It is used to what? Define the size of the teeth. And that is where you decide whether or not the two gears can fit together. That is what you have to know, the size of the teeth. And the measurement is always in what? Millimeters. Bear in mind. If you look at it, it's always in millimeters. Of course, in US, they measure in inches. Right? Since we're using a metric system here, it's always in millimeters. All right? Now, once you have that, then it's quite easy to find the pitch diameter. The letter D here to stand for the pitch diameter. It's very simple. It's actually equal to what? M times N. M is what? M is the match. We just divide it. And what's N? It's a number of teeth. And you can count how many teeth are there on each of those things there. All right? Now, the pitch, remember what's that? The distance between what? Two identical points, right? On two adjacent teeth there. And that you can find that is what? P, which is the pitch, okay, is equal to pi times M. So that's the distance between it. Why do I pass around and you can look at it if you want to? Now just look around and just pass it on. Come on, if you want to look at it then, or and see how it looks like. Yeah, just roughly to let you have some quick understanding of all this here. By the way, you need to memorize all those things. I'll give you all this little formula here, okay? So you just need to know what they are. And now that is a kind of a terminology that we have here. You can see that there's also two circles. So we have the pitch circle, right? Remember that? The one on the top there, we call the outer circle. So this is the outer circle, okay? And this is with the outer diameter. And the small little one, we call that the pitch circle and the pitch diameter here as such. So that's what you have. Oh, by the way, if you have a mobile phone, you can take a shot of the slide if you want to. Okay, you're free to take a slot of the. Just take it if you want to. Okay. Now, I will show you very simple calculation. Now, I give all the little formula here. Okay, m is a module, and so on and so forth. Then now, let's say look at this one here. A gear with module m equal to 3. This is a what? It's a match, right? M is a match, right? And n is a what? Number of teeth. Okay. Calculate the pitch diameter, and then the pitch. Now, how do you do it now? All the formulas are there already. You see that? Very straightforward using the formula, and you can find the pitch diameter as well as the pitch as such. And for the pi, we use up to 3.14. Of course, we can use a bit more digits if you want to, but for sake of simplicity, we use a 3.14 for pi as such then. Now, I think I have my worksheet here for you. Okay, here's some of the notes that you can get it, and you can do some work later on. Now, come on. There you go. Pass it on. Pass it on then. Anything? Pass it on. Pass it on. Any extra? Pass it on. Okay, pass it on. One more now. Take it. Pass it on. Just a minute, huh? Okay. Pass it on. Pass it on. Then come on. Any extra? Pass it back to me. Extra? Don't have? Raise your hand. Anybody got one? Okay. Everyone got one here. Okay. Now look at the calculation again. Come on. So your gear where the module, okay, the m is what? 3, okay? The n is 24, which is the number of teeth. How do you do it? I give you all the formula here. M is a module, okay? It is a module here, so you can see that, pitch diameter is equal to what? M times n, so the 3 times 24, very straightforward calculation. You don't have to think very hard about it. Now give it another one. If you have a gear of 15 teeth and a pitch diameter of 30 mm, can you calculate the module? That's quite simple. That one is what? Just a ratio. Remember, module is a ratio, all right? So module is a ratio which is 30 over 15, which is 2 mm. So that's how you do your calculation here. Now, can you try the first page here? Come on, you can do a simple calculation now. Right here. I'm sure you all can do it. Quite simple. So you all get an answer for the first question? So what's the pitch diameter? Shout out. What's the pitch diameter? Who can tell me? 1A. Huh? 192. Correct? 192. Well, how about the pitch? Pitch. 28. 18.85. All agreed? 18.85. Well done. Okay, so that's it. Now. 18.84 or 85. Is it big? I think it's because it's a rounding, isn't it? It's a rounding. Yeah, it's a rounding here. Now, number 2, the gear has 18 teeth. Pitch diameter is what? 64. Calculate the pitch. What's the pitch? What's the pitch for the second 2A? What do you have? No, take one first one as well. 3. Module, yeah. Sorry. Okay, this is module 1. Oh, okay. Module, Okay. Pitch is what? Sorry, point what? 11.185 mm. Okay, the pitch is, am I right? Let me read the page here. the pitch is 11.185 mm. Am I right? Oh, 19 also okay. I mean, up to you. Okay, fine. You over here. Okay. And then the module is 3.656. Am I right? Well done. This is a very simple calculation. Okay. So you can see that how people use that to do the calculation of the size of a gear. Okay. Now, but how about the two gears that interlock together? That's another thing. Let's look at the next one. Look at the two gears now. What do you notice these two gears? Are they running in the same direction? Turn the same direction there? No. One is what? Clockwise. Another is anti-clockwise. Right. So that's a bit different. But however, when two gears are turning, bear in mind, one of them, we call it a driver gear. That means that gear will drive the other gears. So in other words, in this case, my gear A is a driver gear. Which gear it drives? It drives the B gear. You follow me? So that gear is called the driven gear. So whenever you have two pairs that interlock together, when one of them start moving, that one is called the driver gear. The one get moved by the other gear is called the driven gear. You got it? And you can see that they all move in the opposite directions. The driver gear move in what direction? Who can tell me? What direction? Clockwise. So therefore, this guy must what? In the anti-clockwise direction. Correct. Now, because of that, we talk about the ratio, the gear ratio. Now, gear ratio is quite straightforward. Since we know a number of teeth, all right, of the two gears, I give you one of them is what? 16. The other is what? 24. And then your direction, one is clockwise, this clockwise, the other is what? Anti-clockwise. They just said it. How to find the gear ratio? Now, watch out very closely. I have this letter R to denote the gear ratio. It's the number of teeth of the what? Driven gear for the denominator. Am I right? No, for the numerator. The number of teeth for the what? Driver gear is in the what? Denominator. Watch out. Number of teeth of driven gear in the denominator as a fraction, because ratio is a fraction at the end of the day. Fair enough? So that's how you would write it down. Now, so in this case, where's my driver gear? Gear A, am I right? So the number of teeth is what? 16. It's at the bottom here, all right? In the denominator here. 24 is what? It's gear B, the driven gear. So you work it out. It's 3 over 2 is equal to what? 1.5. Now, let me answer this question. Which gear rotates faster? A or B? A. What does that mean? If gear B rotates one round, how many times will the small A will rotate?
One and a half.
1.5, right. Correct. 1.5 turns. That is what the gear ratio is telling me. Now, watch out. So the meaning of it. Okay? Yeah. When the number is like this, it seems that when the bigger gear rotate one round or make one rotation, the smaller gear will rotate how many times? 1.5 times. So that is the meaning of the gear ratio. Oh, time for lunch. Okay, good. Lunchtime now. We go for lunch.
Do we keep our stuff here?